see keys. Let's see what are keys. Keys are used to distinguish individual tuples. So the tuple is a row in a table. Tuple. Let me just resize my pen. To do it. Uh, yeah, tuple. What is tuple? Tuple is a row. Tuple is a row. So keys are used to distinguish individual tuples. Super key is a set of attributes that uniquely identifies tuple in a relation. Okay. A super it means that the super key is a set of attributes that uniquely identify tuple in a relation. Example, ACT ID is a super key. So is a ACT ID balance a super key? Yes. Every tuple has a unique set of values for this combination of attributes. Uh, is branch name a super key? No. Each branch name can have multiple accounts. Okay, that's why it cannot uniquely identify the row. That's why it cannot be a super key. Let's see. A super key is a set of attributes that uniquely identifies tuple in a relation. Adding the attributes to the super key produces another super key. Okay. Adding attributes to a super key produces another super key. If ACT ID is a super key, so ACT ID balance will also be a super key. If ACT set of attributes K belongs to R is a super key, so is any superset of K. If set of if set of attributes K belongs to R is a super key. Is a super key. So any superset of key. Not all super keys are equally useful. So not all the super keys are not equally useful. A minimum super key is called a candidate key. A super key for which no proper subset is a super key. A super key for which no proper subset is a super key. For account only account ID is a candidate key. Okay, not all super key are equally useful. Remember that. And a relation might have several candidate keys. A relation may have several candidate keys. In these cases, one candidate key is chosen as the primary means of uniquely identified tuple called primary key. Example, customer relation candidate keys could be customer ID or customer name and address both combined. Customer name can be same, that's why it's not no, only customer name cannot be the super key or primary. Uh, so it has to be joined with the address to form a primary key. Choose primary key. So from this, we choose a single primary key, a customer ID, or the customer name and address. So it is better to have a single primary key instead of multiple attribute primary key. So customer ID is better. Let's see. The primary key attributes are required to be non-null. The primary key attribute should be non-null and unique. That is, no tuple can have any null values. No tuple, that is no row, can have any null values for a primary key attribute. And no two tuples in the relation can be equal on all the primary key attributes. Okay. Uh, okay. So primary keys. Keys are property of relation schema, not individual tuples. Okay. So keys are the properties of the relation schema. So the keys are belong to the schema, not the rows only. So they are property of the relation schema, not individual tuples. So applies to all tuples in the relation. So the primary key applies to all tuples in the relation. Primary key attributes are listed first in the relation schema. Okay. Key attributes are also underlined. Key attributes are underlined then first in the schema. An example, account schema, account ID, then branch name and balance. Here, account ID is the primary key. Then account ID is primary key. Then customer schema. Customer schema, that is here customer ID is the primary key. Only indicate primary keys in this notation. Okay, other candidate keys are not specific. Other candidate keys are not specific in this notation. Okay, we what we did is below the primary key we underline the key name. So it is primary keys. Multiple record can't have the same values from a primary key. So, multiple records can't have the same value from multiple records can't have a same primary key. Example, अगर मल्टीपल टपल्स है उसको सेम प्राइमरी की वैल्यू must not be same. Okay, must not be same. Okay, here see customer ID, customer name and address. Here this is the primary key and then this is the primary key. Here it is different, here it is different, but here why it is shown wrong? The two customer cannot have the same ID, but uh, here it's not okay. So this ID and this ID are same, so this is wrong. This should not have been there. The customer ID is a primary key, so it should be different for different tuples. Two customer cannot have the same ID. Okay, key is constant in a relation. Okay, let's see. Primary key is constant. Uh, Primary key constraints. Primary key constraint. Let's see primary constraint set of tuple that can appear in a relation. Set of tuple that can appear in a relation is called the primary key. Sorry, primary key is constant set of tuples that can appear in a relation. Same is true for all superkeys. For a relation R with schema R, if K belongs to R is a superkey, then uh, then T1 for all T1, T2 belongs to R, T1K is equal to T2K such that T1R is equal to T2R. If two tuples have the same values for the super key, that is, if two tuples have the same values for the super key attributes, then they are same tuple. Okay. If two tuples have the same values for the super key, they are same tuple. Which of the following is a possible set of candidates? Uh, let's see which of the following is a possible set of all candidates in a relation. R, A, B, C, D, E, F. So this is the candidate key. This is the candidate. It is possible. Okay. It is not possible. It cannot be null. A, B, C, D. This can be candidate's key. Okay, this can be candidate key A, B, C, D, E. Okay, this can be a candidate key A, B, B, C. Okay, if this is the candidate key, this should not be a candidate key because candidate key is the minimal super key. So if it is joined, if we know the A, we did not need B for to know another tuples because A can identify the whole tuple. So this is wrong. Then A, B, and B, C. Okay, this is possible. Let's see if our answer is correct or not. Yes. This is right, right. This is wrong. Yes, this is right. Okay. Mm, another very attribute is a very attribute is a CK. Okay. Every attribute, every attribute is a candidate key. Every attribute is a candidate key. Okay. In a ABCDE, if ABCDE is unknown, then CK, then maximum. In a relation, there are these tuples. If ABCD is known, okay. Uh, ABCD is known to be CK, then maximum number of possible. Okay. Candidate key will be one and super key will be one. Okay. Let's see the third. Relation is AB. There are ABCD tuple attributes and schema is given as this. So maximum number of super keys possible. Okay, maximum number of super keys possible. So let's say A is the candidate key. A is the candidate key, B is the candidate key, C is the candidate key, D is the candidate key, and E is the candidate key. Uh, okay, so the super keys will be all the combinations of these attributes. That is a number of 2 into raised to the power 5 minus 1. That is 1 is null value that we subtract when subtract. Okay. So it will be 2 raised to the power 31. Let's say maximum number of candidate keys possible simultaneously. Okay. Mm, maximum number of candidates simultaneously. Okay. ABC, if they we know A is the candidate key, okay. So both three A can be candidate key, B can be candidate key, and C can be candidate key, okay. And then AB, then BC, then AC, AB, BAC, then BC, okay. Three. Or okay, maximum three. So if ABCD is given, what should happen? AB, A, B, C, D. Then it can be A, AB, BC, AC, AB, AC, AD, AB, AD. Then BC is possible. Then BD is possible. Okay. Then BC is possible. BD is possible. CD is possible. So how many? One, two, three, four, five, six. Okay, six. Maximum, max is equal to six possible. Possible. Okay. So A1 to AN are set of maximum number of super keys. Okay. So set each AI must be a candidate key. maximum super key is equal to 2 raised to the power n minus 1. Okay. Let's see here maximum number of CKs simultaneously. Okay. Uh, Maximum number of CKs simultaneously should be Cn n by 2. Okay. Our to set maximum number of CKs A, B, C, A, C, D, A, F, B, C, D. Okay. 6, 3, 6, C, 3. Okay. Uh, 6, C, 3. So 6 into 5 into 4 into 3 into 2 into 1. Okay. Then 6 factorial. 6 minus 3, 3 factorial into uh, 3 factorial. Okay. 3 cancel. 3 is 5 to 20. Okay. Fixed. N is fixed. Maxima is and CK. Then what is K? So R K A1 to A set of maximum number of super Ks. Okay. So set each maximum super K n minus 1. Okay. Maxima is N C K. Okay. What is N C K? Is N is fixed. Okay. And then K. What is K? K is equal to floor of n by 2. What is this? Uh, okay, let's see. A, B, C, D, E. And the A is candidate key and B, C is candidate key. Yes, K, yes. So if A is a candidate key, then the possible super key is 2 raised to power 4 minus 1. 2 raised to power 4. Plus, then if BC is fixed, then plus 2 raised to the power 3 is fixed. If ABC both, then 2 raised to the power 2. Okay. Possible, possible, for 4, 6, 8. See today's DSA question. Solving the greedy problem. Okay. Then assign cookies. Let's see this problem. Let's see what is the question. So, assume you are an awesome parent and want to give your children some cookies, but you should give each child at most one cookies. Okay, let's take the screenshot of this. Okay. Uh, assume you are an awesome parent. You want to give children and agree to each child. I have greed factor. Okay. I will note the points. Each, okay, each child has greed factor. Okay. Uh, Factor, which is the minimum size of the cookies that the child will be content with, and each cookie, okay, GI, and each cookie, J has the size SJ. Okay, size of the, okay, size of, okay, it is SJ. SJ. Okay. As size SJ. If SJ is greater than, if SJ, that is size of the cookie, is greater than or equal to great equal, we can assign the, we can assign the cookie J to child I. Okay. Uh, and the child I will be content. Child I will be content means it will be satisfied. Your goal is to maximum the number of content children and output the maximum number. Okay. So it is given here, it is given that G is equal to 1, 2, 3 and S is equal to 1, 1. What is S? S is the size of the cookie that child will be content with. Okay. You have three children and two cookies. Three children and two cookies. The grid factor for three children are 1, 2, 3. Okay, these are the grid factor. And even though to have cookies, you have two cookies. Since their size is both 1, you could only make the child whose grid factor is 1 content. You need to output 1. Okay, so let's see what is the second test case. Uh, You have two children and three cookies. The grid factor of two children are 1 and 2. You have three cookies and their size are big enough to gratify all of the children. You output. Okay. You output 3. Mm, Solving the gradient problem. काय? नाही, मी आलतो येणार होतो मग मम्मी म्हणे राहू दे म्हणे फळा घ्या म्हणे आता तेच जातो म्हणे. काय? Not okay. It says you should sort first. You should sort both the git factors and s because I use 2 pointers. One, okay, use 2 pointers. One for children, one for cookies. Assign the smallest cookie that satisfies them. Okay. Then, if satisfied, move move to the next child. Always move to the next cookie. If satisfied, move to the next child. Always move to the next cookie. Okay, I will try this. Mm, okay. First, int count. Okay, 0. Okay, then pointer int ptr1 is equal to 0. Int ptr2 is equal to 0. Okay, j is equal to 0 and I is equal to 0. Okay. Mm, sort arrays dot sort g, then arrays dot sort s. Okay. Sort gs. I use 2 pointers. Okay. For each child, assign the smallest cookies that satisfy them. Okay. For and I is equal to 0 and x is equal to 0, x less than g dot length plus plus okay, x plus plus. Okay, what should I do? Is assign the smallest cookie that satisfy them. If gx x minus s x